Okay, today we're going to have project day, and what we're going to be making is a very simple, but if you work on radios or even use radios and have one additional piece of equipment, which is an oscilloscope, this tiny little circuit we're going to make can be very handy if you're a sideband operator. And what we're making is a two-tone sine wave generator. Now what you use these for in sideband is adjusting for linearity. Now once we get this built, I'll actually hook up a sideband radio. We can look at it on the scope and see what this is used for. But it's a very easy way to test to see if possibly the bias isn't set properly in your radio. You know, are you overdriving it? Is it not linear? You know, like I say, it's just a handy little circuit, and it's, when I say simple, it's very simple. This is it. Now there's several versions of this. You can go online and print out any, probably dozens of different two-tone signal generators. This is one that I have used before. Works very well. It's very simple. It gets the job done, and it gets it done for a very bare minimum amount of money. It's the heart of it's basically just two transistors. Now this is by Peter Richaud. I'm not sure how the name's pronounced, so if I mispronounced your name, I'm sorry. Call sign Delta Kilo 7 India Hotel. And it's, like I say, the heart of it's comprised of two transistors. Now he uses two BC 5470 or 547Bs. If you don't have those, you can use like an NTE 123, AP, or a 2N2222. You know, it's just a standard low signal NPN transistor. Nothing special. There's a gazillion substitutes for it. Now, I happen to have several hundred of the actual, get it turned around here. I don't even know if you'd be able to see the part number on that. If the camera ever focuses. It's not going to focus on it. There we go. There you can see. C547B. So this is a BC547B. But other than that, the only thing that you need is a handful of other components. Everything you see on the bench is the only thing you're going to need, other than if you choose to put, which I would suggest, but put some type of output jack on it, RCA, BNC. It doesn't really matter. You can just run a set of wires off of it to whatever you're going to be using this with. That greatly depends on your application. For this box, I'll probably, just because I have so many, I have actual test equipment. I have mountains of BNC cables, so I'll probably just put a BNC jack on this one. But I'm going to put this in a little project box. Now, you could very well just stick it on a piece of perf board and just use it just like that. Like I say, doesn't need to be anything special. So all you need, like I say, what you see here on this schematic, and that is two 2.2K resistors, 250K resistors, four 4.7K resistors, 5 10 microfarad electrolytic capacitors. In this case, I'm going to be using tantalum capacitors. They can be aluminum electrolytic, doesn't really matter. You'll need 3 6.8 nanofarad caps and 3 22 nanofarad caps. So here's the 6.8 nanofarads, and then here's the 22 nanofarad caps. I'm just using the little poly dip ones, so nothing special. Get the kind of stuff you can get anywhere. Now for the balance pot and for the volume pot, or potentiometers, I'm just going to use trimmer pots. We're not putting out any massive amounts of power. This is, after all, just two little small signal transistors. So this is, it's not like this thing's pumping out 100 watts. So we don't need anything fancy. Now you can use a normal potentiometer. Now you can just use a trimmer for this balance one, but I would suggest you use some type of actual potentiometer pot that you can put a knob on for the volume, because if you put it in a project box, you should have this accessible from the outside. The balance should be basically a set it and forget it control. So you can put, use a trimmer pot. I like 10 turns myself. You can use a single turn's fine, but I just like the smooth nature when you're tuning stuff of having a multi-turn potentiometer, and these don't cost that much, so I just use a little 10 turn. Now, you see he has 4.7 here. That's kind of oddball when it comes to potentiometers, so we're not going to be using 4.7s. 5 kiloohms or 5,000 ohm is a very standard for potentiometers and trimmers, so that's what I'm going to be using is 5Ks. It works just fine. Now, I'm using this style because I'm actually going to be using, I have a bunch of these little adapters here. And what these do is these turn these 10-turn trimmers into potentiometers with a shaft that you can put knobs on. So you just take this little thing, this has a, get it over the white paper, you might be able to see it a little better. See, it has a little piece that sticks out there on the end. And that actually lines up with the screwdriver slot in the end of this pot here. So that goes in first. And then you just slide your little 10-turn trimmer in there. And it's now accessible. It turns it into a hole mountable. There's our star washer and nut. And now we have a shaft that we can put a knob on. So I'll mount that, in the center of this board somewhere, and then when I, get it soldered on there, I'll lay it out, and then I'll actually drill a hole, and I'll slide this down in, and then I'll also have 2 of these holes. This board wasn't exactly meant for this box, but 2 of the holes lined up, so I just trimmed off a little bit here. But like I say, it'll sit down in there like that. I'll have 2 screws in one side. It's not like this thing's going to be used in mobile applications, so 2 screws is more than enough. Well, like I say, it'll come out, and then I can actually put a knob on the outside here. Now, another thing you can do is optional. You can run this off from 9 to 12 volts. So, if you put it in a larger project box, you can put a battery on the inside. Now, I'm probably just going to drill a hole in it, put a little snap connector for a 9-volt battery on the outside, because I'm just one of those people, I don't like leaving batteries in stuff. So I'll just put a little snap connector, I'll punch a hole in one side, stick a rubber grommet through, run the wires in, and just have a 9-volt battery connector on the outside. But like I say, this other trimmer here, because this is going to be set it and forget it, I don't ever need to adjust this from the outside, so this will just be mounted to the circuit board. We'll adjust this with an oscilloscope so we have even output of the 2 frequencies, and then that's pretty much it. When we're done, we'll have a little working signal generator. So let me get this assembled. It's not going to be any fancy, we're not making any fancy circuit boards, we're just using plain old perf board. So component leads will be, basically shoved through the holes, and then those will become the traces. I'll just fold those, fold those over. You'll see how I have it soldered up when I'm done, but I just usually use the leads themselves as the traces. It's great for little projects like this, and this is a good, simple project if you're just learning electronics, because this is a piece of test equipment, so this will add to your arsenal of equipment that you have on your bench, especially if you do sideband, any type of sideband communications equipment. It's it hardly costs anything. Like I say, you don't have to put it in a project box, so all you really need are 2 little trimmer pots and that handful of little parts right there. So for very, very, very little money, you can make one of these things. I mean, you can make it as fancy as you want, but it can be very simple in design, or not so much design, but it can be very simple in assembly and construction type. So let me stop the video here. I'll get it popped here on the board, no rhyme or reason. I'm just going to basically stick the 2 transistors on here, follow the schematic, and it'll end up looking like whatever it looks like on this perf board once I get it laid out. Whenever I do stuff like this, it's just kind of trial and error, put parts in there, and fiddle around though it looks, that looks pretty good with a minimum amount of solder work on the bottom side. And once I have that together, like I say, I'll get it mounted in the box. I'll show that, and I'll already have the hole drilled in the box for everything. We'll get it put together, and then we can hook it up to an oscilloscope so we can look at it and see what it actually is making. And then we'll actually hook this up to a radio, and I'll explain how you hook this up to your radio, because you're basically just going, this is going to replace the microphone, more or less. That's what you're making, an audio generator. So this is a two-tone audio generator. So basically this little box, the little black box, is going to become your voice, or it's going to become the modulation for your radio when this thing works. So I shall return with a completed board. And the magic of computers and editing, or just the pause button, we now have a completed little board. So here's everything, stuck on a piece of perf board. Had to do a little bit of trimming to get around, just with this box and whatnot, with the standoff for the cover and whatnot. But it'll fit down in there. I still have to drill the holes in the box. But the board's completed, so you can see nothing fancy. I just temporarily have this stuck on there. Like I say, I'm going to leave this on the outside of the box, so I'll desolder those two wires, drill a hole in the box, and put a grommet on it, and just leave this hanging out. That way, every time it's not in use, just disconnect the battery. Coax cable is the output. Then that will be going to a panel mount BNC jack. Well, there it is. Like I say, it's nothing really complicated to it. Just a couple little parts, 2 transistors, and 2 pots, and that's about it. So I've got the oscilloscope turned on over there. So let's get the scope probe hooked up. And we'll hook up a battery. And let's see what we got. Aha! Look at that. We have a multi-tone pattern. So now what I'm going to adjust is, what you're going to see me do is, this is about centered right now. So this one, because this is the one that will be on the outside, I've got a little knob stuck on it right now. And like I said, this is a 90-degree mount, trimmer potentiometer. I just happen to have these nice little spectral mounts, that makes them externally accessible. But any type potentiometer would work. But the other one, that's the balance. Now what the balance does is you have to remember, this is basically 2 oscillator circuits. You have an oscillator circuit here, and an oscillator circuit here. You have a volume control, but your 2 signals come, your signal from this oscillator circuit's coming up this direction, and your signal from this oscillator circuit's coming this way. They meet up in the balance pot right here. And they'll come out of the balance pot and go to the volume pot, and then out through the coax. So what you're doing is moving that wiper on that potentiometer up and down, and you're allowing either more of this signal and less of this one, or more of this signal and less of this one in. And that's what you're doing is you're balancing it back and forth. Which one of these is getting more signal through, and reducing. And the idea is, and you'll see when you do when I have this hooked up to a radio, when you do that balance, you'll see when you reach the perfect balance in the waveform, you'll see what I'm talking about. But so for right now, what I'm going to do is, like I say, that's fairly centered right now. But what I'll do is I'll unscrew it in one direction and then screw it in the other direction. So you're going to see a low frequency when I have it turned one direction, and a high frequency in the other direction. Because right now it's a mix of both of them. Grab my little screwdriver. Actually, let me grab my trimmer. My actual little trimmer tool, because this has the little encased tip on the end there, so it doesn't slip off. Makes for easier adjusting. Okay. Okay, so there's one direction. You can see that was the low frequency. And out to the other end, and there's the high frequency. And you can see it doesn't completely knock off 100%, but this isn't you don't want this to be a one-tone generator in one direction or the other. It's going to be a mix of both. So, it's going to be somewhere roundabouts in there. Going to be about halfway. So, but like I say, once we get this hooked up to a radio, we'll get that balance set perfectly. And then once we have the balance set, we never need really to come back in here and adjust that. I guess what you could do is, I've never really worried about it, but if you wanted to, you could locate that adjustment, you know, where it'd come through on this up top, or, you know, so once you stick the board in there, just take measurements top to bottom, left to right, and then actually just drill a small access hole if you wanted to in this, you know, whichever cover, because these usually come with two covers, an aluminum cover or a plastic one. I usually just use the plastic ones. But, you know, you could drill a small hole in this for an access hole that would allow you to get down in there to that trimmer if you were so inclined, you know, without having to take the cover off. So let me get this unhooked and get her stuck in the box, and then we'll dig out a sideband radio and we'll get it hooked up to the mic jack on that, and I'll show you exactly how this works. Well, if you've stuck with me this long, we now have a completed little black box. I did drill a hole in the top to, you know, access for the balance, so I can for the, you know, the video here, I can easily get down in. You know, look down in there, you can see the little trimmer potentiometer down in there. Also, turn it off. Actually did stick a on-off switch on it. I just have it hooked up to a switch box. It makes it easier for me hooking up the radios and using my foot switch system to you know, inject the audio into the radio. But all you need to do is the audio line from this is going to go to the audio at your mic jack. So, you know, you could take here, let me just reach over and grab some of my test jumpers. I mean, it doesn't need to be anything more complicated than this. Just a mic jack and some wires to hook this up. But anyhow, your audio's, and it's going to, of course, vary depending on what radio you use, what their mic wiring is. But the audio coming out of this will go straight to the audio line in the radio. The DC ground from this, which is, you know, the battery negative and also the shield on here, will go to the mic jack. That's going to go to the shield and ground connection on the radio mic jack. Then the only additional thing you're going to need is to basically have a switching circuit to put the radio into transmit. Now, if you're doing something as simple as this, you know, you could just short your transmit line to ground, or, you know, whatever you're using. And that depends on the radios. Some short to ground, some to a voltage source. It's, like I said, it's very dependent on the radio you're working on, and we're not going to cover that in this video. You know, microphone switching. So I have it hooked up. So what can we do with this little guy? So, like I say, the two-tone audio generators are designed to be used for testing sideband. On AM, all you need is usually most test equipment will have a 1000 hertz tone that's used for audio modulation. But the two tones, and here's what we need the two tones for. So we look up here at the spectrum analyzer. The camera mount decides to not spring away. And I'm going to turn it on and key the radio. So there you can see we have two tones. And then there's some of this other, you know, third order products and other stuff. And then we actually have a little bit of stuff in the middle here. But as I turn the mic gain up and down, we can see this goes up and down. Okay, now what I'm going to do is actually throw it out of balance. So remember that little balance pot I just showed you through the top there. So what we're looking at here is, let me actually turn the audio generator off. So here's AM on channel 20. Okay, so here's an AM carrier unmodulated. If I flip to upper sideband, here's upper sideband. See, the carrier's been suppressed. It's not perfect. This radio has not been worked on. This is still an all-factory original radio. So, you know, however it was aligned back in the 80s. But this is the suppressed carrier in upper sideband, and this is the suppressed carrier in lower sideband position. And then if I add modulation, and then if I switch modes from lower sideband to upper sideband, you can see that they've shifted their position, because the carrier is here. So this is doing that, using this two-tone generator in AM. So there's upper sideband and lower sideband. But what each of these represents is one of those two audio tones. So if I use the balance pot to throw it out of balance and reduce, if I can get it in there, so you can see this audio tone is now starting to disappear because I'm throwing our audio generator out of balance. And it's almost completely gone there. And then if I go the other direction, So we got rid of the low frequency audio tone. Now we're going to go the other direction, and we're going to remove the high frequency audio tone. And you can see the high frequency audio tone goes away, and the low frequency comes back. And I'll spin it back the other direction. I'll adjust it for a balance right about there. So that's almost perfectly balanced. And actually we can take some, so what this is useful for is, if a radio's, let's say, is non-linear, or has problems with like the bias circuit or something, so I'll key the radio in, and what I'm going to adjust is the driver and the finals bias pots on this. So like I said, I need to recap this radio, it needs lots of work done to it, so, you know, let's assume we're starting out with a radio, the bias is all screwed up. That's what happens. And it just went into calibrate mode. Give it a second. Okay. So, there I cranked the pot full one direction, and you can see what happens when the bias is completely out of whack. You can see what as it comes up. We don't want all this shit. The only thing we want is this. All that is distortion products that we don't want. And then if I adjust the driver transistor bias, we can get the same thing. We can get it to down there where we do want it, and you can see as I swing the other direction, the distortion products start to come up, and if I put it back, you know, close to where it should be, see how all those distortion products disappear. Actually, if we go in, let's see, measurement, actually, let's see, first thing, let's get this centered. And we'll go into measurement. Darn it. Measurement. Third order intercept. So third order intercept. And what do we have to span? Or no, measurement. Okay. So this is we're measuring third order intercept, or we're actually going to be measuring the third order intermodulation or distortion products. So you can see, so what this is, it's an automated setup that it runs through, but it's measuring the two audio tones, two little blue arrows there, and then you'll see there's also two arrows down here. And those are the third order intercept, or the third order products. And you can see, again, if I throw the driver bias out of whack, how those third order products start to come up and what we do want, because this is the information that we're wanting to transmit, the actual audio tone. We don't want the distortion products. So you can see what happens if the bias is not adjusted properly in a sideband radio. We want to keep these two numbers here as low as possible, because that's what's measuring here. We want these top numbers to be as high as possible, because that's the actual two audio tones we want to be transmitting, and then we want to keep the two bottom ones here as low as possible, because we want a minimum amount of distortion. So what we want is a DBC as high as it can get, because we want the maximum amount of separation between these two peaks. And you can actually measure the intercept here. And you can see how that comes down. So that's what it looks like on a spectrum analyzer. So let me pull the plug on the radio and plug it into my BK1040, and then we can look at it on the oscilloscope down here. And I'll key the radio again. I'll have to get it in sync. And there we can see there's a good looking waveform, sideband pattern. We can see it crosses over, it pinches down to 0. Nice, smooth, rounded over, sinusoidal looking waveform. You know, it's a perfect wave. Now you can also see as I throw it out of balance, if I throw, let's say, the two-tone generator, so I'm going to reach in here and adjust our balance inside the little two-tone generator. I may have to adjust the sync to keep it stable. Nope, no, it's going to stay pretty much. But you can see as one audio tone disappears, then we just end up with basically a CW signal, because that's what basically we have now. We have a suppressed carrier and a single audio tone for modulation, so basically we have a CW signal right there. And then if I bring the other signal back in, bring the balance back to center and swing the other direction, the same thing happens. We're removing the one audio tone, and then I'll bring it back to center again. And right there. Now, same thing with the bias pot. If I adjust the bias pot inside the radio, you can see how that has a huge effect on, you can see how our actually signal's going down here. Well, that's where, when we were looking at the spectrum analyzer, when you saw those two outside peaks starting to come up, that's actually where it's going down here. Okay? Because that's getting all distorted now. And the same thing if I do the final, over here to the final and adjust it, you can see, yeah, that's definitely not what we want. We don't want golf balls with a straight line in between of them either. So there's just some of the uses. It's handy for diagnostics, doing all kinds of stuff. And like I said, I had this little, I just put it in this little box here, and I've put the, I did put an on-off switch on it. Like I say, I always like to have my batteries outside. That way I can just disconnect it. You know, I don't have to worry about leaky batteries. Now, like I say, I use rechargeables, but, you know, it doesn't need to be any more than something as simple as this. That basic schematic, 2 transistors, a couple pots, and, you know, you can make it as complicated or simple as far as mounting, or if you want to stick it in anything and whatnot, but that's all you really need to do two-tone sideband testing. Now, like I say, with the addition of an oscilloscope, you can then actually see your modulation package and see if your sideband signal's, you know, distorted or not. So, you know, break out some parts and have at it. I hope somebody finds some use from this and, you know, make one and have at it.